and how you can use it for testing vulnerabilities or issues that you think are necessary within your contract, right? So that is basically what we wish to do today. And specifically, we are going to fork the mainnet and see how we can use StarkNet Foundry at least to generate proofs of concept. So I didn't want to do basic testing because as I know that you also have a background in, you understand Cairo, you've been able to do to write Cairo contracts. So I think that would be too basic. So I decided to let's do something interesting. So so we know that StarkNet is a toolchain for writing, right, and deploying, testing smart contracts. So it's inspired by Foundry. Basically, the Solidity version of Foundry, StarkNet Foundry, it's StarkNet version of it. So before installation, you need to have SCAB installed. So that is very, very, very important. There's a script that is already out there. You can use the StarkNet Foundry book to get the script, and then you simply write this command, and then you'll be able to be set up. So I'm glossing over these things basically because they're also found in the StarkNet Foundry book. So I wouldn't wish to spend a lot of time. I just wanted to point out a few things as we go by, and then we get into the meat of our class today. So you basically use this command. One, it will initialize a folder, and in this folder it will have all the components that are necessary for this toolchain to work, right? So for example, in this project name, you'll have three important files that you need to take care of. So here you'll have the lib.cairo file, test, you can store a test. Here you can have your contracts, whatever. Here is because StarkNet Foundry uses CAB as its package manager, so all the configuration will be found here, and then basically, right? So I think that's quite straightforward. So in this class, I wanted us to fork the mainnet. There's a vulnerability that happened late last year. Understand the vulnerability, and then try to reproduce that hack using StarkNet Foundry to be able to generate a proof of concept. So basically, that is our class today. So there was this security alert that was given by the StarkPepe community where they lost a significant amount of money, and basically their contracts were hacked. So this is the Twitter announcement that they made regarding the security issue that they had faced, right? Now, so we have that at the back of our heads, right? So we understand this is the hack, and so how can we reproduce it? There are certain things that we need first to be able to ensure that we fork the mainnet, right? So for us to be able to fork test the mainnet, this is not now normal testing. You need to point out your Foundry test to a specific fork, right? So there are two flavors or two ways of doing this. You can either specify an RPC URL plus the block number if you so wish, but it must have this keyword here called fork. So of course everything will be under the test, under the function signature of test, and then it must have this fork. So basically what you're doing, you're telling the test using fork state to run whatever is in this function, but run it on this blockchain now, on this block number, using this specific RPC. Now, whatever we are doing, whatever we are putting under URL and block ID, so we are using a macro from SN4 from StarkNet Foundry, right? So from StarkNet Foundry, there is an enum called block ID, and it takes two parameters: the URL and also the block ID. Alternatively, you can do option 2, where you now configure your SCAB file And then your scab file under dependencies, you add this. So you can add a name, whatever name that you want, and then the RPC URL that you're using, the block ID, it must have a .tag, right? So it has a tag can be latest, so it can be .tag or .number. Again, you can look at the StarkNet Foundry book to understand more about it. So when you tag the latest, it will fork the net that either the main net or it will fork the main net or the test net from that specific number. But if we add the word latest, it will fork the latest blockchain. So we need this we can do either of these. You can do it directly per test or just configure the scab the TOML file so that it will have this. The beauty of scab, when you're writing these fork states, you can have numerous. So you can have fork 1, fork 2, fork 3, fork 4 with the different blockchain numbers. And then you'll be able to call it here, as we'll see in the next example. Now, so this is what we did, right? So I went with option 2 because it's easier. One, you'll be able to reproduce and you don't have to rewrite it every time you do a function. So here I named the test. As you can see here, the way you write it, it's fork, and then this is the first method, and the second method, instead of writing the entire URL plus the block number, you'll just write the fork name that you've done. So in this case, you can write some name here. We are forking some name, and then Foundry, the test case, the test suite itself will be able to come to the configuration file and see this. So basically, that's what we did. Now, Nethermind they have an RPC, a free RPC, which you can check it out here, and then you'll be able to use the RPC. Yes. Now, So about the hack, about this hack to be specific, about this hack. Okay. Question. Okay, it's like the StarkNet tooling ecosystem forgets. Your name is so hard to pronounce, so I wouldn't even attempt to pronounce it, right? Because I think I'll just pronounce it.
It's Temi.
I'll call you TH. So TH. Temi. TH. Okay. Yeah. I think. I don't know. Yes, most like developer-minded ecosystem, even Ethereum forgets about Windows, to be honest. Come on. Yeah, I think everyone forgets about Windows. But I think Windows these days have WSL, so you can just write like that. So, but anyway, you should shift to something like Ubuntu or any Linux player or something. Anyway, I digress. So, in this Pepe hack, there are two things that we were able to get, right? So if you analyze the hack, as we will see later, the hack basically because they said that around 11 p.m. I did a little bit of digging, and then I found the transaction, one of the transactions that the attacker was able to use to hack into the network, of which I'm going to show you later. But at around this time, the block number at this time was this. So I picked this block number because this was well within the period with which this hack was happening, because it happened over various transactions. So yeah, so again, this is how you do it. So, and as I said, block ID, the macro has a tag. You can use the tag latest, or you can use the number which is here. Okay. Now, so having the two things that we have, we understand the hack. We understand the hack happened at a specific transaction, right? So how can we be able to replicate? How are we able to replicate this hack? right? So you see. Yeah, so a minute. A minute. Two. Okay, yeah, so we are back. So I think I've been able to correct that. Yeah, basically there was a slide that I had forgot. Now, this is the hack. This is the, I've been able to, I queried the transaction, right? So under Voyager, this is what you get. A snapshot of the entire thing, right? So we can see the block number here, which is exactly what we use here. Now, question. Who can, from this snippet of the transaction, who can say something about the possible thing that occurred? What can you read? What can you read? That is now a question to everyone. Kazim. I'm sorry, I hadn't. Kazim. So we have the hack. This is one of the transactions that the attacker was able, and basically this is where it like showed where the issue was. Yes, Kazim, please go ahead. You can unmute and say what you think, or you can text via chat.
Okay. So based on what we have here, I guess there is vulnerability at the transfer points. Though this was not showing the function which was used in the hack, but at the end of the day, the tokens were transferred from the account, from the contract to this account wallet or to this wallet contract, and with the sum of
yes. Sorry, continue.
With the sum of about 161 million StarkNet people.
Yeah, I get you. Thank you so much for that. So there was a hack. Stack Pepe tokens were stolen. So yes, thank you for the observation. Another thing, okay, with reproducing hacks, you are basically, when you go to transactions that shows the vulnerability, you're working backwards, right? It's after the fact. So there was a hack that happened. This is on the transaction. You're trying to like replicate the attacker's action, or you're reproducing the attacker's steps to be able to understand possibly what might be wrong. So what is off? Well, I need you hacker minds. Thank you, Kazim. What is off? What is you say TH, please?
I don't know if it's normal, so I'm quite new to StarkNet, but the from and the to seems to be the same address.
Think, and that is the problem, right? So we can see that there was a transfer function from the same account to the same account. Now, normally this is not a normal behavior, right? So it's like sending money to your own self. So, and there was value. So other transactions, you'd see that the value increased, right? So if there was a self-transfer, then some sort of value would increase, which shows that the contract itself, an accounting fault where if you self-transfer, your tokens would basically increase, right? Now, the contract was not verified on messages, or as people are discussing through this, it was clear that there was fault in self-transfer, right? So getting such a function was really helpful. Now, how are we going to interact with that, the deployed contract, replicate the acts of the hacker, and see the results to be able to at least see where the problem was? Able to, we need an RPC or L, and also the blockchain ID. So this is the blockchain number that we're going to use, right? Now, secondly, we need to now, not even secondly. So when you're forking, a fork test is just like a normal test, right? So when you're writing tests in StarkNet Foundry, as tests are here under this test directory, so it is just basically the same test. You just need to write your function with the test parameter in it, and then declare whatever. But now in StarkNet, even in Solidity, you need to declare an interface. It's like we know that even in StarkNet, you need to have an interface, and an interface tells you which functions are you going to call, and are they state modifying functions or whatever. So we need to declare the function signatures that we want to call, right? So as seen here, we would wish to call transfer function signature because the hacker was able to use this. It would also be important for us to call the balance off signature, right? Or should we call the balance off so that we'll be able to track the balances before the action or after the action, right? Now, so yes, I'll get to your question, TH. Just let me just finish, but I've seen your question. I'll come back to it now. So this is important. So we first, as we are writing any contracts, we are testing, we have to declare an interface, input the function signatures we wish to call, and also because we are using like contract address, we'll have to do necessary importations, right? We will use start prank. Why should we use start prank? Because we want to mimic the actions of a specific caller. We can use a cheat target, print tray to be able to print the balances. And then because we are calling contract address, we'll use the StarkNet contract address. And then this, I'll be able to talk about this in the next slide. Now, so the function, remember, our fork, we called it stack fork. So in here, we called it stack fork, right? So here we are able to it's again under test, we are able to write the fork name stack fork with parentheses. So what Foundry will do, it will be able to go to stack fork in the configuration file and then pull the URL this URL that we have declared, as well as pull this block number that we have declared, and then run this test called test using fork state with those specific parameters. Now, the first thing we needed to declare an attacker. So again, I know you understand Cairo, so we declare a variable called attacker. It is of type contract address, and then because this is the address of the attacker, we wanted to use this address of the attacker to mimic the exact actions, right? There are many reasons why I did that. One of them because at this point the attacker had like stack paper token, so I didn't want to go through the hassle of like providing my address with with CoinCTC, like funding address CTC. So I just wanted to like replicate this action of this specific app. Yeah, so we have the contract address. Now we imported this felt250 to try into contract address. So this is a hexadecimal, right? So it is a felt element. This. So we are converting the hex into try address. So that's why we're using this felt252. We are converting it into a StarkNet contract address. So that's what we are doing. Now, the contract address, again, we'll do the same thing. Now, this is the StarkPepe, the deployed StarkPepe contract. This it's the deployed StarkPepe contract, and of course we'll have to declare dispatcher, because we understand in StarkNet we need to have a dispatcher contract so that we'll be able to interact with it. And every contract has a dispatcher where we are able to interact with it. Now we do this. We queried the balance before at a previous block. Remember we did. So we queried the balance, and then we use print. So again, the print trade from StarkNet Foundry, we import it here, and this is what we do. The second thing, we now pranked. We wanted to be the attacker, so this is how you do pranks. You start prank cheat code. Again, you can read more about it in StarkNet Foundry, and then we self-transfer, right? We call a transfer function 2, and the 2 we declare our own address as the attacker. Remember here we pranked ourselves as the attacker, right? So the from is the attacker, and the 2 is the attacker address, and this attacker address is declared here, right? And then we query the balance. So this is how the entire code looks like. You can basically just pull this code and paste it into any StarkNet Foundry file, into a test file, and then when you run SNForge, you'll be able to query. Now, here's the result. So when you do SNForge, remember this huge balance that we were talking about, we were able to transfer. So self-transfer doubles the amount. So this is the result. Remember, we are doing 2 print treats. So we are querying the balance after, and then we are querying the balance before the self-transfer, and then after. Then with that, we are able to see now if somebody was able to do a self-transfer in the StarkPepe contracts, their funds would basically double, which shows that there was a very serious issue in the logic of the smart contracts when it comes to contract transfer. So someone did a self-transfer, the amount doubled. They're able to do that on one day. Yes, so that's it. That's it for me for this class. I wanted to demonstrate the usage of StarkNet Foundry through how you can do fork testing and how you'll be able to the importance of fork testing as a security auditor or a security researcher is you're able to replicate all mainnet actions and be able to analyze and see how certain hacks happened. How did this hack happen? As much as maybe in some occasions you might not have the full information. Okay, questions. So is there like a Ghidra or idea for Cairo Bytecode? I know. Yes, it's not hard. It's really not hard. So long as you just have basic testing, it's easy. The hardest part about it is you understanding where the hack is and getting the specific transaction where a specific hack happened. But most protocols, as I've observed through Solidity, they've been able to, like, you're able to see the transaction where the hack happened, and then you see, you read through the code, you find the specific actions that a hacker did, and then you just replicate that. But it would be important if you have like the entire code, so you are able to read. Oh, Kazim, yes, you are raising your hand. You have a question.
Okay, so when you were setting up the fork test, you made use of the block ID, and I'm curious that is the block ID going to be for that particular block, or any, like, the transaction? It's a take up on, you can mimic any transaction from that block ID to the latest one? Or is it going to be?
No, so when you declare block ID and you do a block number, basically that test happens on that block number. So it mimics the state of the blockchain at specifically that block number. Now, if you can declare multiple forks, so like I can have stack fork 1, stack fork 2, stack fork 3 with the different blockchain numbers that I want, or if the attack is not block deep enough, right? So it's a live hack, it's a live vulnerability that you look like and they say like it is existing in the blockchain, right? So if it is existing in the blockchain already, you don't need to declare. You can use the latest, which will give the latest state of the blockchain from the latest block number. So block ID depends. So for this case, I got this transaction and it happened on this specific block. So I chose the specific block because I really wanted to mimic the actions of the hacker, because they were able to inflate their balance in block 485 to 52. Yeah, because if we read here, you see it's 485 to 52. So I just used the lower block to be able to replicate this action. So instead of 252, I used 251 here to be able to just prepare myself for this action, so that I'll be able to see this, probably what happened. Yeah, so when you use a block ID, you want to test a specific block number. If you want to use the latest, use the block.latest. Or if you're going to iterate your test over several blocks, maybe you can have different forks for the different blocks. The beauty of StarkNet Foundry is every test can have their own unique forks, right? So, for example, this test using fork state uses this. You have to declare this to be able to use the fork state. So I can have another function test something, and then I fork stack fork 2, like another fork environment. So I hope I've answered you, cousin.
Yeah, thank you so much.
Welcome. So yeah, is there any good idea for okay. So I'm really not sure. Next week we'll talk about fuzers. I know there are tools such as TOF that let me just I know it does assembly and disassembly of Cairo Bitcoin to some degree. I'm not so sure. I know there are a number of tools. I think Carabal or something. I'm not so sure. I'll have to look at it. Yeah, so basically that's it. So I wanted to encourage you also. Yes, Kazim.
Sorry, please, I ask questions.
No worries.
From what we had, is there possibility where we have much like having for a situation where we have how do we call this in-call function, like I've forgotten the name they use for it, like for an instance, if you want to replicate a transaction where you have, for an instance, I believe this one is just one function. We have some transactions where we have multiple function call within a particular function. In that situation, is it possible we have everything in the transaction, like while replicating it in the distance?
Absolutely. In fact, this is the most basic. We can have as many. In fact, let me give you an example. So let's say we have a staking contract, and I'm talking as if some of you, I'm sure you know a staking contract. So you have the staking contract where you stake, but let's say you stake a stablecoin, something like a USDC. So in that case, you'll have to declare two contract interfaces. One will be for the USDC, because you'll have to call that the contract, let's say the stable coin, if it's a Stark coin or an ETH coin or an USDC or a USDT, you'll have to declare the interface. And secondly, you also have to declare the interface of the staking contract that you're using. So when you declare the interface as this, you'll be able to now directly do it like this. So you have like this an ERC20 dispatcher. So just say let Stack Dispatcher equals that one, the interface that you want, right? So whatever dispatcher and the contract address, right? So that's it. So you'll have to declare the various contract address. You can have, like, let's say our hack interacted with 6 different contracts. You'll have to declare the 6 contracts, and then of course they'll have their own interfaces, and then interface has an interface dispatcher. So you have to declare it like this, and then call them like stack dispatcher.stake to be able to replicate. Yeah, so it can traverse different functions. You can have 101 functions within our test case. I hope that answers it.
Yeah, thank you.
Welcome. Yeah. So that's it, guys, from me today. We'll be able to dig more. I'd really encourage you to look at StarkNet Foundry, run a few test cases on your own. Just read about it and interact with the tool. And I know there's a new version of StarkNet Foundry, 17.1, if I'm not wrong, that was just released like today. So you can have a look at it and then interact with it, and then the more you try, the better that you become. So that's it from me. And if in case you have any other questions, you'll be able to talk to David, push to him the many questions, and then we'll be able to tackle it on our class in Friday.
Okay. Thank you very much. Thank you,